Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 9, Lesson 11 on constructing tangents. This will be our last construction lesson of the course, and we're going to be looking at two ways to construct tangent lines. In one situation, we'll look at how we construct a tangent line to a circle given a point on that circle. And the other construction that we'll look at is how we construct the two tangent lines that go from an exterior point to a circle to a given circle. All right, let's get right into it. Now, tangents and radii. Tangents to circles are important in a variety of ways. We can construct tangents to circles at a given point on the circle, and we can also construct tangents from an exterior point on the circle, as I mentioned. First, we will review an important relationship between a tangent and the radius it intersects. Exercise number 1. Line M is tangent to circle A at point B. What is special about the relationship between line M and radius AB? All right, now this is going to be important for both of our constructions today. Pause the video now and tell me what's important about this line, M, and the radius that intersects it at point B. Well, they're perpendicular, and we proved that a few lessons ago when we first saw tangents and their relationships to circles. So they are perpendicular, right? To be very clear, right, they form a right angle. Right, and that's going to be absolutely critical for both constructions that we do, not surprisingly, because it's one of the most important relationships that tangents have with circles. All right, now some essential constructions. Since right angles and perpendicularity are important when it comes to tangents, we will first review two important constructions from Unit 4 on perpendicularity. So let's take a look at exercise number 2. Review the following constructions from Unit 4. Letter A, construct the perpendicular bisector of segment AB shown below. Using this construction, label the midpoint of AB as M. All right, so let's review how to construct the perpendicular bisector of a segment. Now we've done this many times, but let's go through it because it has been a little while since we've done it. Here we go. So follow along with me. What I'm going to do is I'm going to take my compass and I'm going to put the center of the compass at one of the two ends of the segment, and I'm going to stretch the compass's radius out so that it is greater than half the length of the segment. I'm now going to use that radius, and I'm going to try to keep the point of the compass on point A, and I'm going to draw an arc, hopefully draw an arc, maybe not. Let's bring it down here. Let's see if my pencil lead will work down here. Okay, we're going to draw an arc below the circle with that radius, and an arc above the circle with that radius. Oh yeah. Now what we're going to do is, keeping the same radius, we're going to flip our compass around. We're going to put the center of the compass on point B. Rotate our compass up, hope that it works. It does. Rotate our compass down. Continue to hope that it works, and it does. And now, as usual with our constructions, X marks the spot. So we can now draw a line in between those two intersection points. And what we'll end up having is the perpendicular bisector of segment AB. Now, because that's the perpendicular bisector, the perpendicularity will be important for us, but so will the bisecting portion. It must go through the midpoint of the segment. All right, so a very important construction in terms of what we're going to be doing today. Now, let's look at another important construction for the day. Letter B. Construct a line that is perpendicular to line M, shown below, and passes through point A. All right, so this is a very similar construction, except in this case what we want to do is we want to construct a line that is perpendicular to M and is guaranteed to pass through A. So here's the key to this construction, right? We're going to bring our compass over to our line, and we're going to put the center of the compass on the point that we want our perpendicular line to pass through. We're going to open up our compass to a certain amount, and we're going to draw an arc with that radius on both sides of A. Now, before we move on, just a little note, right? What we've done when we do this is we've guaranteed that A is the midpoint of a segment that starts and ends at the two intersection points that we just made with those arcs and the line. So now what we're going to do is we're basically going to construct the perpendicular bisector of that segment, right? So from here on out, we're going to do exactly what we did in the previous construction. We're going to put the center of our compass on one of those two intersection points, stretch it out just a little bit further so it's more than half of the length of that quote segment. Then we're going to rotate it down. We're going to get it again down here. All right, rotate it back up. Switch so that our compass now has its center at the other intersection point of the arc and line. Again, drawing that arc, and down below, an arc again. And get rid of our compass, it's done its job. Now we just have to connect those two intersection points as best as we can. And now what we've done is we've constructed a line that passes through A and is perpendicular to M. And those are two good constructions to know anyway. All right, they're two of the more common constructions that you might find on a standardized exam. All right, and both of those constructions are going to be useful when we look at the actual ones that we're trying to achieve and learn today. All right. So now let's take a look at the first one that's new for us. Constructing a tangent through a point on a circle. So let's take a look at exercise number 3. Using the construction from exercise 2b, construct the tangent to circle C below at point A. All right, so what I want to do is I want to draw the tangent to the circle, construct the tangent to the circle that passes through A. Now keep in mind what I know about that tangent line. What I know about that tangent line is it will be perpendicular to the radius that's drawn from C to A. So the first thing I'm going to do this construction is I am going to draw a line segment that passes through both point C and point A. All right? And you want to make it plenty long. Okay? Now what that does is two things. One, it establishes the radius CA. Okay, but the second thing that it does is it really hones in on what I want to do now. I now want to draw a line that is perpendicular to the one that I just drew in and that passes through point A. Because that'll do the job, right? I know whatever line I've got has to be perpendicular to the radius CA and has to pass through A. So that's exactly what I'm going to construct. I'm literally going to do the construction we just did, except I want a line now perpendicular to that one that passes through A. Pause the video right now and see if you can do that construction. All right, well, let's do it. I mean, literally, the construction is sitting right here. Of course, for you, it's just simply in the exercise above. I'm going to put my compass right there on point A. I'm going to widen it out. It doesn't have to be a lot. I just want to find 2 points that are equidistant from A on either side of it. There we go. Now I'm going to move my compass over to one of those intersection points, stretch it out a little bit further. Because remember, all I'm trying to do is do exactly what we did in the last construction. I want a line that is perpendicular to that blue line and that passes through point A. So I'm going to make that set of arcs. Now I will switch my compass around, put the point of the compass on the other endpoint, make that arc, and make this arc, and get rid of my compass. It's done its job. And now I bring this down, X marks the spot. Let's get it as good as we can. And let's draw that tangent line. That is satisfying right there. There it is, right? Perfect, right? All we had to do was recognize the fact that whatever the tangent line was going to be that passes through A, it had to be perpendicular to the radius drawn from the center of the circle to point A. So we just draw, a nice segment that goes through C and A and extends further, and then we just do that construction of constructing a perpendicular to a line through a point on that line. And that's absolutely it, right? I have definitely seen this type of a construction show up on at least the New York State standardized exam in geometry. And again, it's understandable because you knew how to do this construction way back when, we were doing constructions in Unit 4. All right? So now let's take a look at the other construction. Now, constructing the tangent to a circle at a given point on the circle is relatively easy to do, and I hope relatively easy to understand, right? However, constructing the two tangents from a point outside of the circle to a circle is far more challenging. Before we learn the construction, we will investigate the essential geometry behind it. And I always kind of debate this. Should I show you the construction first, which would just be like step 1, step 2, step 3, or should I kind of explain the geometry first so that the construction makes more sense? This time what we're going to do is we're going to investigate the geometry first, then we're going to do the construction. So let's take a look at exercise number 4. In the following diagram, circle C and circle B are drawn and intersect at point A and another point that's not labeled. Letter A. Explain why, given circle B only, that angle PAC must be a right angle. All right, and here's what I mean by that. Just for a moment, assume that circle C isn't even here, right? And all you have is circle B, right, with PA drawn, PB drawn, and AC drawn. I want you to explain to me, and this comes from this unit, why angle PAC must be a right angle. Pause the video now and see if you can explain why that must be true. All right, well, it's kind of easy, right? PAC, since A is lying on the circle, angle PAC is an inscribed angle, right? And specifically, it's an angle that's inscribed in a semicircle, right? It intersects arc PC, which is a 180-degree arc. Now, we know that the measure of any inscribed angle is half the measure of the arc that it intercepts. And since it's intercepting a 180-degree arc, right, it's intercepting arc PC, then it must be half of that measure, so it has to be 90 degrees. All right, so let's write that down, right? Angle PAC is an inscribed angle that intercepts a 180-degree arc. And maybe I'll just put a little parentheses here. That's going to be arc PC. Therefore, since it has a measure of half the arc, it must measure 90 degrees, right? And that really has almost nothing to do with circle C. So you might be like, all right, where are we even going with this? So let's take a look now at letter B. Explain why, given part A and radius AC, so now we're bringing circle C in, PA must be tangent to circle C at point A. All right? Well, pause the video now and think about this a bit. I claim now, given now the whole picture and what we just saw in letter A, that PA must be one of the two tangents that you can draw from point P to circle C. It's got to be one of those tangents. Pause the video now and think about why that has to be true. Well, what do we know? We know that CA is a radius, right? And we know that the radius will be perpendicular to any tangent drawn to it at the particular point of tangency. We also know that CA must be perpendicular to PA because we just established that in the last problem. There's only one line that goes through A that is perpendicular to CA. That's got to be the tangent line, and since PA is perpendicular to AC, or CA, it's got to be the tangent. So let's get all of that down, right? CA is a radius, is a radius, so it, is perpendicular to the tangent at point A. Since AC, actually, let's keep it the same. Since CA is perpendicular to PA, this means PA must be that tangent. All right. Now finally, and this is going to be the final key to the construction that we'll see in just a moment, letter C, what special point along PC is point B? So in other words, let me just kind of give you a sense for where we're going with all this. Eventually we're going to have a circle, circle C, and point P not lying on circle C. And we're going to want to construct the two tangents from P to circle C. So what is point B? Because that won't be there originally in the tangent construction. What special point is that? Pause the video now and see if you can answer that question. Well, point B is the midpoint of segment PC, right? B is the midpoint of PC, right? Because it is the center of circle B. All right. So where does this leave us? Well, let's take a look at this really kind of cool construction. I always love saving this construction as the last one that we do in this course because I think it's really kind of cool. And it will seem kind of involved, but ultimately it's not too bad. Let's take a look at exercise number 5. The diagram below shows circle A along with exterior points P and Q. For each exterior point, construct the two tangents from that point to circle A. Leave all construction marks. All right. So here's how we do this construction. And let's do it together for point P, and then we'll have you try it for point Q. Now what we're going to start with is we're going to start by drawing a line segment from the exterior point to the center of the circle. Not past it or anything like that, just to the center of the circle. Now, I need to draw that second circle. And what I need to do is I need to find its center. But its center will simply be the midpoint of this particular segment. So what I'm going to do is I'm going to do the perpendicular bisector construction on this segment for one reason only, to locate its midpoint. Okay, if I could locate its midpoint in a different way, I would. But the only way to locate the midpoint that we know of is to create the perpendicular bisector. So let's create the perpendicular bisector in order to find that midpoint. Now that's the first one that we reviewed today, so I'm just going to take my compass, I'm going to stretch it out so that it's more than half the length of that segment, and that's really critical. My big mistake is sometimes I won't end up getting it more than half the length, and then I got to redo the thing. I'm going to draw an arc up here, as usual. Let me go up here, grab this thing, get my arc then drawn down here. All right, again, I'm just doing the perpendicular bisector construction in order to find the midpoint of segment PA. Oh, just barely. There it is. And down here, hopefully I got this one. I did. Excellent. Okay, I'm going to put my compass away for right now. It's going to come out again. Now what I want to do is I want to just draw that perpendicular bisector. And again, the only reason I'm doing this is to locate that midpoint. All right, so I draw my perpendicular bisector. Pretty close, not perfect, but pretty close. And now I've got that midpoint. Now, before we move on, I just want to kind of like go back one scale, and I want to take a look at this diagram again. Right? We started with this circle and this point. We drew in this segment, and then we used the perpendicular bisector to basically locate the center of our second circle. right? Because it's the intersection of the two circles that's going to become important for us. Those are going to become the point of tangency, but I needed to locate the center of that circle by finding the midpoint of that segment that I drew. Now we just need to draw that circle, and that's easy enough, right? I'm going to bring my compass over here. I'm going to put the center of my compass on that midpoint. Stretch my compass out to either point P or to point A. It doesn't really matter. All right, I'd really like to have it right on point P as close as I can. Okay, oh, that's not too bad. And that was the hardest part right there. Because now what I know is I know those two intersection points are actually my points of tangency. And watch how nice this looks. Right, I'm going to really just kind of draw these in. These are my points of tangency. So now to construct the tangent line is easy enough. All I have to do is put my straight edge. Oh, please don't move. I can't believe that just moved some. That was unbelievable. And that will be one line of tangency. And then rotate it down, and that will be my other line of tangency. And that's it, right? And it's really kind of a cool construction that takes into account a fair amount of the geometry that we did in this particular unit, right? It takes into account the fact that a triangle that's inscribed in a semicircle has to be a right triangle. It takes into account the fact that the radius will be perpendicular to a tangent that's drawn, all sorts of things like that. I want to see if I can lock this thing down real quick so that it doesn't move on me anymore. There we go. But, right, what are the essential keys, right? The essential key is to construct this second circle whose intersection points with our original circle then are the points of tangency from that exterior point, right? How did we do that? We drew in this particular line segment, which really is a diameter of that extra circle, right? We then had to find the midpoint of that diameter using the perpendicular bisector construction. Once we had that midpoint, we then just had to construct or draw that extra circle in, and then those intersection points became our points of tangency. I'd like you to pause the video now and see if you can do it for yourself from point Q to the circle. All right, well, this is going to get a little messy, but let's go through it. Okay, step one. Let's first get the diameter of that circle that we need for this construction. So the first thing I'm going to do is draw a line segment between point A and point Q. Okay, I now have to find its midpoint. So I'm going to put the end of my compass on one of the 2 points, stretch it out so that it's more than half the length of the segment. Get myself a nice arc there. Bring it below the segment. Another nice arc. Okay, switch so that now the center of my compass is at point A or the other point. Rotate up, try to get it on point A. Get myself that arc and get the arc again and put my compass away for the moment. Draw our perpendicular bisector in as well as we can. This thing's not behaving for me as much as I want it to. Get rid of my ruler at the time. That locates the center of my second circle. This time the center of that second circle lies within circle A. Not that that really matters too much. Now stretch out my compass so that I can draw that additional circle. Not too bad. Not too bad at all. Now it's the intersection of that circle with my original circle that gives me my points of tangency. I now can bring my ruler down, my straight edge down, and draw my points of tangency in. There's one of them. And whoops, almost. Try to get that a little bit closer. And there's the other. Now that's a complicated looking picture, but still, right, it gets the job done. And it's a remarkable construction. You know, it really is. It's a little bit gimmicky, right? Let's be honest about it, because, you know, there's probably very little chance that you just sort of like think of this construction off the top of your head. Oh, I should connect the exterior point to the center of the circle, find its midpoint, draw a circle with that diameter, and then find its intersection points with the original circle. And of course, those have to be the points of tangency, right? Again, hopefully the previous exercise made it clear why those have to be the points of tangency, but it's definitely sort of a deep level construction in terms of all of the geometry that goes behind it. Certainly much deeper than the first one we did, where all you're doing is extending, you know, the radius from the center of the circle to the point of tangency and beyond, and then drawing that perpendicular line that goes through that point, you know, and is perpendicular to that radius. That one's pretty easy. This one is a little bit more involved. All right, let's wrap this up. Now I'm not gonna lie to you, I'm gonna miss constructions. We're not gonna have any more for the remainder of this course. All right, that is it. But these are important constructions because not only do they review some of the construction techniques that we saw earlier in Unit 4, but they also, you know, really reinforce much of the relationship between tangent lines and radii of circles. And of course, that essential idea that tangents are perpendicular to the radius drawn to the point of tangency. Really, really important. All right, well, I wish I could say you're going to be using these a lot throughout the rest of the course, but you aren't likely to. So I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.